Good morning. Today we are going to discuss sequential circuits. Se- Combination circuits, as you know, you have a circuit and the output depends only on the current inputs. That means you have a set of inputs and processing that you will get as a group of outputs. And in this case, in the case of sequential circuit, past history of outputs are also required. That means the output of a sequential circuit not only depends on the present input but also depends on the previous output also. That means the current state of the sequential circuit depends on previous state of the sequential circuit plus the current input. Okay, that means here past history of outputs are also required. That means not only depends on the current input, the output of a sequence circuit depends on the past output also. Okay. Now, past output is known as memory. Past output is otherwise known as memory. Depends on the past output as well as the current input, and the present input is both of them collectively forms the present input. That means past output as well as the present input both of them collectively forms the present input. Okay, a combination circuit, that means a sequential circuit can be considered as sequence circuit can be considered as a combination circuit with memory. That means previous output, that means sequence circuit depends on the previous output also. This previous output act as the memory. Okay, that is output of next state. Next output depends on previous output and current input. This is the pictorial representation of that. This is the sequence circuit. These are the present inputs, and this is the past output, and the past output is stored somewhere. This is the storage space, and past output is stored here, and that past output is also fed as input to the sequence circuit. And the current output means next output depends on the past output as well as the present input. That means here we are going to give the present input, and this is the history. That means the previous output is stored here, that is also passed as input to the sequence circuit, and the next output or next state depends on the present input as well as the previous or the past output. Okay, that means this depends on this as well as this. Okay, now we are going to discuss what are the memory components in sequential circuits. As you know, a combination circuit plus memory, that means a sequential circuit is actually, if you are processing this present input and you are taking the output, that means if this depends only on the present input, that means it is a sequential circuit. Here this not only depends on the present input, it also depends on the past output also. This past output is treated as a memory. For that you require some storage location or some tools or some circuits are needed for storing this memory component. For that we are using latches as well as flip-flop. Latches and flip-flop. In a latch, how to store a 0 or 1, that we are going to discuss. That means in binary number system or in your computer, everything is stored in the form of zeros and ones. How to store a 1, how to store a 0, that we are going to discuss. Okay, now how to store digital data, whether it is 0 or 1, how are we going to store that? That is using latches as well as flip-flops. Memory means some information given must be retained unless it is changed. That means you should have some storage location. If it is a secondary storage device, you can easily do that because it is a magnetic element and we can permanently record data there. So even if there is the power is off, it can retain that information. Here in this case, but these are all volatile devices, transistors and all. So if you are going for memory, some information given must be retained unless it is changed. That means you are storing a bit somewhere, and unless it is changed, it should be there. So for that, you need some mechanism or some circuit to for the implementation of that. For that, we are using latch. Latch means to store 0 or 1, you need a latch. That we are going to discuss basic storage element. Latch is the basic storage element. We have SRLatch. SRLatch means this is S stands for set and R stands for reset. Set reset latch. How do we implement this? There are two types of latches. One is NOR SRLatch. That means an SRLatch which is constructed or which is implemented only using NOR gates, and NAND SRLatch means we are going to have a latch which is having only NAND gates. Okay, now we are going to discuss what is a NOR SRLatch. NOR SRLatch. Here, this is the representation for that. Here we have two NOR gates. That means this is not a 4, and here these are two input NOR gates. Only two inputs are there, and this is R pin. That means this is the reset input and this is the set input. Set and reset inputs, and this is the current output Q, and always this Q bar will be the complement of this Q, and the output of this output is fed as the input to this, and the output of the second NOR gate is fed as the input to the first NOR gate, and this is the pictorial representation of how this is the way you are going to implement an SRLatch, and this is the truth table for a NOR gate. That means A and B. If these are the two inputs, it will return 1 if both A and B are zeros. Otherwise, it will return 0. That means this is the implementation of NOR gate, or this is a truth table of NOR gate. And see, this is the way. That means set reset means if you want to set, then S will be 1 and R is equal to 0. If you want to reset, then S will be, set pin will be 0 and reset should be 1. And if you have to retain the previous output, if you have to retain your previous output, you are going to have S equal to 0 and R is equal to 0. That means this is called memory element. That means I will show you, or I will explain you how this can be implemented. And in the case of SRLatch, S equal to 1 and R equal to 1. That means this is not used. Okay. See, suppose that S equal to 0 and R equal to 0. S equal to 0 and R equal to 0. And suppose that this is 0. The output, the current output is 0. Suppose that this is 0 and R is equal to 0 and S is equal to 0. What will happen? This will be the input here, and if this is 0, Q bar will be 1. Okay, and here that will be 1, and what will happen? This is 1 into 0. 1 or 0, it is 1, and when it is complemented, you get 0. What about this? When that 0 is for here, 0 or 0 is 0. When it is complemented, you get 1. If you feed this 1 here, then 1 or 0 is 1 and the complement of 0. That means this is stable. That means if your S and R are zeros and Qn, that means the previous output. Qn means the previous output is also 0. What will happen? The next output will also be 0. Next output will also be 0. Suppose that this is 0, 0, 1. That means here, if this is 1, then q bar will be 0. Now what will happen? What will happen? If this is 0 and definitely this is equal to 1, then 1 over 0 is 1, and when you take the negation it will be 0, and that 0 is fed here. 0 into 0 is 0. If you take the negation then it is 1. That means it is stabilized. That means if your input is set reset are 0 and 0, what will happen? It is retaining the previous information. That means if Qn, the previous output is 0, then it is retaining that 0. If it is 1, again it will retain that value. That means before this R and S is set to 0, whatever is Q, then that will be retained. That means this when R is equal to 0 and S is equal to 0, it is acting as a memory element. Okay. Now, what will happen if R is equal to 1? That means 0, 1. That means 0, 1. 0, 1. Suppose that this S is equal to 0 and R is equal to 1. S is equal to 0 and R is equal to 1. Suppose that R is equal to 1 and S is equal to 0. R is equal to 1 and S is equal to 0, and the current output is 0. If this is 0, definitely this will be 1. What will happen? What will happen? That means this is 0. Again this will be 0. 0 over 0 is 0, and that will be 1, and when 1 is fed here, 1 over 1 is 1, and the negation is 0. That means definitely that will be 0. That means 1 and 0. If reset pin is equal to 1 and S is equal to 0, if the previous input is 0, what will happen? The current input also is 0. Now what will happen this? If this is 1, what will happen? If this is 1, definitely this will be 0. If this is Q, then this is Q bar. And what will happen? Then here it will be 1, and 1 over 0 is 1, and 1 over 0 is 1, and if you give, then 1 over 0 is 1, definitely this will be 0, and this is 0, and 1 over 0 is 1. 1 over 0 is 1, and if you complement that, this will be 0, and when this 0 is fed here, what will happen? This is 0, 0 over 0 is 0, and if you take the negation, this will be 1, and now this will be 1, and 1 over 1 is 1 and 0, and 0 is fed here, 0 over 0 is 0, then they take the negation 1, and that is stabilized. That means here the previous state was 1, and that is reset to 0. That means whatever be the value of Qn, whatever be the value of Q, if it is 0 or 1, when R is equal to 0 and S equal to 0, what R equal to 1 and S equal to 0, that means when reset pin is 1 and set input is 0, then you have to reset. That means whatever be the current value of previous value of Q, then the current value of this will be 0. Okay, that is why here R is equal to 1 and S equal to 0, 1, 0. Whatever be the value of this Qn plus 1 will be 0. Okay. Now, what will happen if S equal to 1 and R equal to 0? That means this is for setting Q. That means set Q. That is the meaning. Setting means, suppose that this is 1, 0 and the current input is 0. What will happen? If this is 0, this is definitely 1. See what will happen? 0, then 1 over 0. Here, if you take 1 over 0, it is 1, and if you take the negation, then this will be 0. And 0 is fed here. 0 over 0 is 0, and this will be 1. Then this will be updated to 1. Then 1 over 1 is 1, and if you take the negation 0, 0 over 0 is 0, 1. That means stabilized. That means If the previous state is 0, that is updated or set to 1. Okay. Now if it is 1, what will happen? If it is already 1, 1 0, and if it is already 1, what will happen? 1 1 or 1 0 0 0 0 1. That means that will return that information. That means if s equal to 1 and r equal to 0, whatever be the value of q, it will set. And if s equal to 0 and r is equal to 1, that q will be reset. And when s equal to 0 and r is equal to 0, it will return the previous information, previous value, whatever be the value of previous value, that is retaining that information. In that case, it is performing, or it can be used as memory. Okay, s equal to 1 and r equal to 1 is not used. Now we are going to discuss NAND SRLatch. Now what will happen if s is equal to 1 and r is equal to 1? Now what will happen if s equal to 1 and r is equal to 1? S equal to 1 and r equal to 1. What will happen? S equal to 1 and r equal to 1. Suppose that this is r is equal to 1 and s is equal to 1. Suppose that this is the previous value is 0 and suppose that the 1. See, this is the current value. Anyway, these two are complements of one another. That means q and q bar are complements. That means 0 and 1. Now what will happen if r is equal to 1 and s equal to 1? Then this 0 is available here. Then what is 1 or 0 is 1. If you take the complement, this will be 0. And then this 0 is fed here. What will happen? 1 or 0 is 1 and this is 1, this is 0. That means both of them will be 0. In that case, if qn is equal to 0, qn plus 1 is also 0, qn plus 1 bar also is 0. That means these two are zeros. That is not a valid output. That means both of them are 0. Suppose that here this qn is equal to 1. That means suppose that this is 1 and this is 0. What will happen? Suppose that this is 1 and this is 0. What will happen? See, forget about these inputs. And initially r is equal to 1 and s is equal to 1 and the previous value of q is 1. Then what? This 1 is available here. 1 into 1 is 1. If you take the negation, this will be 0. 1 or 1 is 1, and if you take the negation, this will be 0. And that 0 is fed here. What will happen? 0 or 1 is 1, and again this will be 0. And when this is 0, what will happen? 1 or 0 is 1, and the negation is 0. When 0 is given, 1 or 0 is 1 and 0. That means that will also be 0. That means that is why we are neglecting or we are discarding. That means not used. Okay. That's why we are discarding that input. NAND SRLatch. Here, this is the representation. That means here we are using two NAND gates and the inputs to these NAND gates. Here, see, this is not. That means the outputs are Q and Q bar. The output Q is fed as the input to the second NAND gate, and Q bar is the input to the first NAND gate. And here, when you are comparing this with NOR SRLatch, the difference is here 1 1. In the case of S and R are 1 1, then memory is acting as memory. Here this is S bar R bar latch, means this is S is equal to 0 means this is active. That means when S bar is equal to 1, sets Q is equal to 1. That means when in the previous case when S is equal to 1, then Q is set. And when R is equal to 1, in the case of NOR latch, when S is equal to 1, Q is set to 1, and when R is equal to 1, Q is set to 0. Here in this case, there is a minor difference. When S bar is equal to 1, that means when S is equal to 0, this is active. That means when S bar is equal to 1, sets Q is equal to 1, and when R bar is equal to 1, it is setting that Q is equal to 0. All other details regarding this is compared to our NOR SRLatch, and you can do that as a homework. You can do that as a homework, and this is the NAND SRLatch. Now we are going to discuss flip-flops. Flip-flop is nothing but a clock latch. Clock latch.